Okay, welcome back, students. So, we have left from here our previous section. That is, we have discussed some of the things about the types of diagrams, rules of preparing the diagrams, about the diagrammatic presentation we have started. And we have left for the next session is the simple bar diagram. So now we will be discussing this simple bar diagram. So in a simple bar diagram, the data is related to one variable. Okay. So when a simple bar diagram is used, when one variable has to be depicted in the form of diagram. So such as like profits, investments, then exports, sales, production, etc. Will be whenever you will be having one variable, you can very well depict it in the form of simple bar. So this type of diagram may be drawn either vertically or horizontally. So it is not always that a bar diagram should be drawn either vertically, okay, only vertically. So these bar diagrams can also be drawn horizontally also. We will see. I have illustrated one illustration from the vertical and one illustration from the horizontal. So you will be more able to understand this thing. Okay, and whenever you will be having any doubt, so I have put the new chat box on my right side, so you can simply type down, okay, and I will be able to see the chats. So now both positive and negative way. One thing is both you can show in the horizontal as well as in the vertical way. Other way is in this particular type of diagram is that positive and negative value can be presented. So in such case, if a bar is constructed vertically, say for example, I am constructing a bar diagram vertically. So the positive values will be taken on the upper side of the horizontal axis and the negative values will be taken on its lower side. So now let us take an example of illustration, that is prepare a simple bar diagram from the following data relating to tea export. Suppose we have this table related to tea export. We have year and exports in million kg. So exports in million kgs has varied over the years. So it is a variable. Okay. So it is having, this table is having one variable. So from it we can see that in 1995 to 96, 167 million kg of tea has been exported. In 96, 97, 209. Likewise, then in next year it is 410, then 316, 192, 215, and 160, as so on. So we will be making a bar diagram of it. So we have already through the principles of making a bar diagram. So simple bar diagram, I am showing you this simple bar diagram here. I am just minimizing it a little bit that you will be able to see whole of the diagram in one. So uh, the top is the title of the bar diagram. That is figure 1, simple bar diagram showing the tea export in different years. Okay. So it is giving us the context, that in what context this diagram has been made. So it has been made in the context of tea exports. Okay. So simply by seeing the title, you can understand that this diagram is particularly showing the tea export. Now it have a vertical axis. The vertical axis as a principle has to be started from 0, and I have taken the scale of 100, that is 100, 200, 300, 400, 500. Why, how I have decided? Because the lowest one is 160 and then the highest is 410. We need to have anything above the 410 on the scale. And if we take the 100, so it becomes 0, 100, 200, 300, 400. Now, on the horizontal axis, that is the x-axis, we are depicting the different years. That is from 95 to 96, then 96 to 97, 97 to 98, like this. Okay. And from this diagram, I have shown the bars which are of equal widths and having a equal distance between them. Okay. So that they can very well be arranged and can be identified from each other. Then on the top, I have shown the values depicting from each year. That is in 1995-96 it is 167, then 209, 410, 316, 192, 215, and in last 2001 and 2 is 160. So what is the beauty? Because if you see this particular table, then you might not be extracting much of the information from the table. Okay, you will be extracting the 410 is the maximum. Okay. Now, but if you see this particular diagram, this a little bit, uh, this 170. Okay. So from here you can see that there is an increasing trend from 1995 to 1997. That is from 167 it has increased to 410, and then there is a decreasing trend over the next 3 years, and then it has stabilized to its previous values. So this is the purpose of a bar diagram, that it is showing you the trend, that is outlining the trend. It is also showing you that in 1997 the maximum value is there, whereas in 2001 and 6 minimum value is there. Okay, so like this you can say that the nearest value are in the 1996 and 1999 and then, and but one has to show all these things in textual presentation. You should not say that 410 is maximum. You should tell that in respect to 1995, it is the 167, how much percentage has increased. Okay, so it has to be in the form of percentage or in the number, or you can simply minus 167 from 410 and tell that this much of million kg more export has been done in 1990. So that is in the textual presentation. This is the diagrammatic presentation, and this is the your tabular presentation. Okay. So now, on the other hand, if the bar are constructed horizontally, now these bars are constructed vertically. So it is a vertical simple bar diagram. If you construct them horizontally, the positive values are taken on the right side of the vertical axis, whereas the negative values are considered on the left. So this type of construction of bar are also called as, what they are called? They are called as deviation bar diagrams. So the simple bar diagram is very easy to prepare and to understand the level of fluctuation from one situation to other. Okay, so what they tell? They tell from this we can understand the levels of fluctuation as I have described in the bar diagram. It should be kept in mind that only length is taken into account and not the width of the this bar. So only the length of the this bar diagram is taken into account. So width should be uniform for all the bars, and the gap between the each bar should be normally identical. So now let us consider another illustration, that following is the data of the profit and loss of different industry in 1999 and 2002. So we have to make a simple bar diagram out of it. So we have certain industry like cement industry, oil industry, textile industry, sugar industry, garment industry. And if this row shows the variable, that is the profit and loss in lakhs among these industries. So 4825 textile industry was in loss, then this garment industry was in loss during the 1999-2002. So first will be your title of the bar diagram. Then you have a vertical axis, and it all the bar diagram should start from the vertical axis originating at 0. Okay, this should be considered. Then there is a scale of 10 among the horizontal axis, and then industries are shown on the this y axis. Y axis, because it is a horizontal type of simple bar. So all these industries has been shown here, and at the end every data points has been shown that what does this signifies, and there is a title of the vertical axis as well as the title of the horizontal axis. Okay, so this is how a horizontal bar diagram can be constructed and can be shown. Okay, now coming to the multiple bar diagram. So in this type of diagram, two or more than two bars are constructed side by side. When it comes to multiple bar diagram, two or more bars can be constructed side by side horizontally. for a period or related phenomenon. When there are particular same period, three different variables are there, so they can be shown side by side, and such type of diagrams are called as multiple bar diagram. They are also called as compound bar or clustered bar diagram. So if somebody asks you make a compound bar diagram, so you should not be confused. These are also known as cluster bar diagram. The technique of preparing such a diagram is same as that of simple bar diagram, but on the one hand, what it allows is that it facilitates the comparison of the values of different variables. That is, at a time, we can compare the values of different variables in a set, and on the other hand, it facilitates the comparison of values of the same variable over a period of time. So you will appreciate this thing when I will be showing you the multiple bar diagram. So, to facilitate easy comparison, the different bars of a set may be colored or shaded different. Okay, so different colors should be used so that they can be differentiated from each other. And but the color or the shade of the bar representing the same variable in different sets should be same. Okay, that is same variable at different periods. Their color should be same. So now let us consider one illustration again. In this particular table shows the foreign investment industry-wise inflow in crores, and these are the three different years in which chemical industry, engineering industry, service and food industry. This is the foreign investment in crores received in these industries. So let us see that how to make a multiple bar diagram of this. So particularly in this, if you see this, I will make a little bit less that you can see. So it has a top title, that is multiple bar diagram showing the inflow of foreign investment in selected sectors during 1997-2000. And what are these selected sectors? Chemical, engineering, services and food. Okay. Then this is the vertical axis. It starts from 0, and you see that chemical all are blue in color. Engineering all are red in color. Services all are yellow in color. All are green in color. So what it signifies is that within the same year, you can see that chemical maximum foreign investment has been received in case of engineering, let it be 1998 or 99. Although you will see that there is a decreasing trend in the engineering, whereas there is an increasing trend in the chemical industry from 1997-98 to 1998-99. Similarly, an increasing trend has been obtained in service industry and decreasing trend in case of food industry. And within the same year, you can see the maximum foreign investment was in engineering, followed by the services, then in the chemical. So this is the beauty of multiple bar diagram, that you can compare within a group, that is within a year, as well as between year for the same variable, for the different variables at a same time. Okay. So this has been shown already. Now comes your next is the subdivided bar diagram. So in this type of, I am increasing this. So in this diagram, one bar is constructed for the total value. Only one bar is constructed for the total value of the different components of the same variable. Further, it is subdivided or proportion. Is subdivided in proportion to the values of the various component of that variable. So you will be able to understand this thing when I will be showing you the. Okay. So this diagram shows the total of the variable as well as the total of its various components in a single bar. So there is a single bar in that you can find out the total as well as the various components within it. Hence, it is a clear that a subdivided bar serves the same purpose as that of multiple bar. The only difference is that in case of multiple bar, each component of variable is shown side by side, whereas in construction of subdivided bar diagram, each component of variable is shown one upon the other. So in that it was side by side in multiple bar diagram, whereas in this particular This is 1 upon the subdivided bar diagram. It is 1 upon the other. It is also called a component bar diagram. The other name of this particular diagram, subdivided bar diagram, is component bar diagram. And this method is suitable if the total values of the variable are small. One of the requirement is the total value should be small. If it could be high, so the length of the bar diagrams becomes very high. Okay, so the values, total value should be other, and the scale becomes very low. If it happens, if they become very high, so scale becomes very low, and we will not be able to depict the data clearly. So, to study the relative changes of all the components may be converted into percentages. Okay, one can convert all the components into percentages also, and then draw a subdivided bar diagram. And such a bar construction is known as subdivided percentage bar. Nothing is there, instead of the values you convert them into percentages, and I will tell you how to convert this into percentages in pie diagram, which is coming down. Okay, so similarly you can do it here also. Okay, so the limitation is that all the parts do not have a common base to enable us to compare accurately the various components. So in particularly multiple pie diagram, everything is at zero, so you can compare one from the other. Okay, so this is the limitation of this thing. So we have an illustration that following is the relates to the India's export of electronic goods. Okay, from 1994 to 19. We have to represent it in the form of subdivided bar diagram. So these are the years, these are the different countries, and this is the total export in crores. Okay, and from these countries, this much of export has taken place. So for construction of subdivided bar diagram, first of all, we must obtain the total export value of the 5 countries in each year. So these are the total values. And however, in the above illustration of different countries, the total export in each year are given. So how we have to construct it? You can see from here, I am making it that you will be able to. This is the top is the title, that is subdivided bar diagram showing the India's export of electronic goods to different countries during 1994 to 99. Now this is the Germany, this color, then green color is for Singapore, yellow is for Malaysia, and this one red is for Hong Kong, and the blue is for USA. So from here you can see that there is a increasing trend in the USA. There is also increasing trend in the other countries also, and the width of these shows the how much was there, that is 275. It is this 467 is greater than 275, and this data is for Singapore. So this is how vertical axis is there, and total has to be shown on the top. Okay, so maximum export is in the year of 1998-99, and here you can compare the share from each. That is, this 900 is quite bigger than this 130. Okay, which is from the German. Okay, so this is how a this subdivided bar diagram has been formed. Now comes your pie diagrams. So pie diagrams are generally used to show the percent breakdowns. When you want to show the percent breakdowns, so for instance, we can show how the budget is allocated to the different heads. Okay, so a pie diagram is a subdivided, actually it is a subdivided circle. The area of different subdivisions in a pie diagram are in the proportion of the data to be represented. So while making comparison, pie diagram should be used on the percentage basis and not on the absolute basis. Okay, and how to do that we will be telling you. So in constructing a pie diagram, the first step is to convert the various values of the components variables into percentages, and then the percentages transposed into the corresponding degrees. That is, first you have to convert the values into percentages and then convert the percentages into corresponding degrees. The total percentage of various components, 100 is taken as 360 degrees. That is it around the center circle. And various component, the degrees for the various component can be calculated in the proportion using this formula. How? That is 360 degree divided by 100 into component percentage. So simple, we can say that 3.6 into component percentage. Whatever component percentage you will be getting, you can multiply it by the 3.6. So you will be getting it in the degree. So it should be noted that in case the data comprises more than one variable to show two-dimensional effect for making comparison among the variable, we have to obtain the square root of the total of the each variable. Okay, so this square root would be represent the radius of the circle. Okay, so actually I'm not illustrating this particularly here because two-dimensional we have not taken, one-dimensional only we are taking. So if we want to show a two-dimensional pie diagram, so along with the degree, you can also show the radius. That is, compare the radius of the circles also to show that which one is bigger and which one is. Okay. So this is a illustration 5. So a researcher for a simple pie diagram. Okay. So a researcher made an inquiry about the source of price information tapped from 550 sample farmers in a regulated agriculture market as given below. Present the data in the form of pie diagram and comment. Okay. So source of price information they were asking from the farmer, that from where you got the source of price information. So the 50 farmers told we got it from radio, some told we got it from daily papers, then 100 from local traders, then 310 from co-farmers, then 20 from personal visits, and then 10 from the market office. So it constituted almost 550. So the number of farmers who express their source of collecting information for price of agricultural products has to be first converted into corresponding percentages and then into degrees. Okay, so how to do? Once they have been converted into degree, so then the degrees can be drawn in the form of a circle using a protractor. Okay, now we'll just bring it down. So this is the table. So earlier we have this much of table with us. Okay, now we have added two more components into it. Okay, so percentage of farmer. How to get percentage of farmer? 50 divided by 550 into 100. So it will be up to one decimal place we take 9.1. Again 60 divided by 550 into 100 becomes 10.9. Then 100 divided by 550 into 100 is 18.2. Okay, so like that we make that how much of percentage of farmers are there. It total has to be constituted to 100. Okay, so from radio 9.1%, then from 10.9 from daily papers, 18 from local traders. Okay, like this they have come to know about this price. So it has to be converted into degrees of angle. That can be done using multiplying it with 3.6 and then converting it into degree. So you do not take any point in this because it will be very difficult for you to make it in using a protractor. So it will be 33 degree, it will be 39, 65, 203, 13 and 7. So it all constitutes to be 360 and a complete circle. So this is your pie diagram. It shows the sources of price information of regulated agriculture market tapped by the farmer. So from market office 1.8 are there, from personal visits 3.6 are there. You can see that different colors has been used and these angles has been there in the slides. That is particular for local traders, it is around 65 degree. Okay, this price. Then this one 56.4 co-farmers. This co-farmers 56.4. So this angle 56.4 is equivalent to 203 degree. So if you calculate this angle, it will come out to be 103 degrees only. So this is how the data can be represented very well using a pie diagram. Coming to structure diagrams. Okay. So there are several important diagram formats that are used to display the structural information and these structure information are generally qualitative in nature. So the format depends upon the nature of information and basically there are two type of these structure diagrams we will be discussing here. One is the organizational charts and other is the flow chart. So what is a organizational chart? So these type of charts are most commonly used to represent the internal structure of a organization. Okay, there is no standard format for this type of diagrams, and as the diagram depends on the nature of the organization, like what is that organization and what is their structure, and a special format is used in the particularly this following illustration, which describes relates it with the organizational structure of our university, that is Sardar Vallabhbhai Patel University of Agriculture. And you see in this particular figure that there is an organization, chancellor is there, and below that vice chancellor is there. Then there are three bodies are there: academic council, board of management, finance committee is there. Then there is faculties are there. Then dean pgs is there, registrar, controller, director research, then director extension are there. And among these faculties we have College of Agriculture faculty, Biotechnology, Veterinary, College of Technology, College of Basic Science, like this. Under research, we have research centers, research stations. Then we have Director Extension. Under them, there are Krishi Vigyan Kendra. Then there are the Krishi Vigyan Kendras. So Krishi Gyan Kendras and Krishi Vigyan Kendras. So we have these. So this is the organizational setup of our university. Similarly, another type of structure diagram is flowchart, and these flowcharts were discovered by Gilbert in 1921. Frank Gilbert have discovered these flowcharts, and they are also called as process flowcharts. Then Mogensen has credited with training business people on how to use this. So flowcharts are used most commonly in any situation where we wish to represent the information which flow through different situation to its ultimate point. Okay. Ultimately, this is nothing but the flow of information. How a information is flowing. So these charts can also be used to indicate the flow of information about various aspects like material flow, product flow, fund flow, etc. So most people are only aware of some of the basic symbols like processes and decision blocks, but there are many symbols those can be used in a flowchart to make it more unique. And these symbols are like this. If you are processing some data, so you can use a rhombus. Then for processing triangle, for decision making in parallelogram. Then document for document is start and direct data, store data, manual input, and use each one. Then for internal storage, then if you have already a predefined process, you can use this. Then sequential access storage, you can use this type of symbol. So now following is the one flow chart of a patient call at clinic. So if there is a incoming call, so staff has to answer. Then whether they are asking for a specific staff. If yes, then staff from this front desk. If yes, transfer to the front desk staff. Then it might resolve its problem. Call has ended. If no, then transfer the call out of the office. If here it is a no, then this is a decision. Then a appointment is related. Is it appointment related? Yes. Is it a new patient? Then new patient scheduling. Okay, already this is a predefined process, so it has to be put in such type of box. Then if it is no, then existing patient scheduling is there. So like this, this is an example of a flow chart, and this completes our structural diagrams. So this is all from today, and it completes our textual presentation, then tabular presentation, and the diagrammatic presentation. Then from tomorrow we will be starting our graphical presentation. So because there has been no question on the chat box, so I will be leaving from here today. So we will be having a class tomorrow at 2 o'clock. I will let you know on the WhatsApp. Okay. And this is all from me. We have studied three type of presentations in this class. So thank you very much for your patience.